This week, lecture 1 is on algebra, and being able to do algebra, in fact, is assumed knowledge for this course, but we are going to spend some time because we think you're going to be rusty. Okay? So this, I'm not assuming that this is the first time you'll have seen algebra, so therefore the pace will be relatively fast for the first couple of weeks, simply because I think that you've seen all this before. If that's not the case, then you might have to sit at home and do a little bit of extra work. Okay? So I'm just forewarning you that we go fast early and then we slow down once we get into the newer stuff. Okay? I'm just trying to fend off your criticisms even before I get going. All right? So let's go. So in the course notes, we are covering topics 1.1 to 1.7 today, and that takes you from page 9 to page, halfway down page 15, I think. Okay? So that's, if you're going to look into your notes, that's the relevant sections in there. So these are just my, if you like, I've just extracted the important bits, I think, out of the notes here. So first of all, topic 1, algebra. What is algebra? Algebra is just working with numbers when you don't know, when you're not certain which numbers you're dealing with. So in other words, I know this thing's a number. For example, this expression here, a plus 2a equal to 3b. The a and the b stand for numbers, I just don't know which numbers they are. Okay? So, if you know how to do arithmetic, you know how to do algebra. If you know how to add two numbers, here's algebra, just says add them up. Okay? So for example, if I were sitting here, so with that expression here, if we were doing this, if I said to you, add 7 plus 2 times 7, you could say to yourself, yeah, that's 7 plus 14. Or alternatively, you can say, I've got one lot of 7 plus 2 lots of 7. That's the same as 3 lots of 7. And likewise here, if I've got a plus 2a, I don't know what a is, so I know that that is a plus 2a will be 3 lots of a. And then minus 3b, I don't know what that is. I'll put that in there. So in here, let me put in here, so if I had 7 plus 2 lots of 7 minus, say, 3 lots of 5, we said that's the same as, because we know our arithmetic, 3 lots of 7 minus 3 lots of 5. Again, I could say, look, that's 21 minus 15, that's 6. Or I could say, look, I could also write that as 3 lots of 7 minus 5. That number and that number are the same. Now up here, I can't calculate 3a. I can't say that's 21 because I don't know what a is. But I can certainly do this step. So I can write that as 3 lots of a minus b. Okay? So the fact that I knew what to do with numbers means I know what to do in my algebra. So always, always, if you get stuck in your algebra, think, what would I do if I actually had some numbers in here? And that hopefully will get you unstuck. Okay, I'm going to come back and deal with a lot of the operations I just did here further down the track, but that's the idea sitting in there. Okay, so that's what algebra is. So to start with, we're going to talk about algebraic expressions. So an algebraic expression is just some calculation that involves numbers and pronumerals. That's an example of an algebraic expression. I've got numbers and I've got pronumerals in there. I've got a variable, if you like. And the first thing we'll start off with is the idea of finding the value of an algebraic expression given particular values of the numbers. And so that's fairly easy in here. First of all, if I have this algebraic expression, when there's no operations mentioned, it implies we mean multiply. Okay, so in here, no operation written says we agree, it's just a convention, it means multiply in there. So in here, 2ab, when a is equal to 5 and b equals to minus 2 is just 2 times 5 times minus 2. So there you go. Then what have I got there? 10 times that will be minus 20. So that's all you have to do. Everywhere you see A, substitute 5. Everywhere you see B, substitute minus 2. So substituting into formulas, into algebraic expressions isn't too difficult, I hope. So let's just do a few more to show that algebraic expressions can involve all sorts of things. As you can see here, we've got a more complicated algebraic expression here. So here if I have 5a cubed b plus 7xy, when a is equal to 2, that will be 5 times 2 cubed times b, which is 5. So you can see in here I have the implied multiplication. Likewise, plus 7 times x, x is 8, and y is a quarter. And then you just evaluate that, do that calculation. So what have we got here? We've got 8 times 25, that's 200, plus 2 times 7 is 14, so I end up there with 214 is my substitution. Algebraic expressions, of course, don't have to just involve multiplications and additions. They can have all sorts of other things in them. For example, here, that's supposed to be a B and a C in there, obviously. Here in part B, this says find the square root of x times y. And that means here times the square root of 4 times 9. 4 9s are 36. The square root of 36 is 6. Remembering that our square root sign means the positive square root. So that symbol is the symbol for the positive answer. Because we know that I can multiply minus 6 by minus 6 to get 36. That's the positive square root. And here's a more complicated expression. It's still an algebraic expression. It involves numbers and pronumerals, and it says evaluate this when r is a half. So this is 20 times a half. T is minus 5 and w is minus 1. So I've substituted in there, and our division thing here acts like a grouping symbol. It says calculate the numerator, calculate the denominator, then do the division in here. So I'll calculate the numerator. 20 times a half is 10. In the denominator I've got minus 5 minus minus 1, so that's plus 1, so that's minus 5 plus 1 is minus 4. So that's the same as minus, and I can write that as 5 on 2 in there, cancelling out the common factor of 2. And if I so desired, I guess I could write that as minus 2.5. So it wouldn't matter how you wrote that, whether you left it as an improper fraction or a mixed number, it wouldn't matter, I don't believe. So in each case, in the algebraic expression, we've just substituted for the pronumeral.